Hi everyone and welcome back. Today we are going to solve the lead code problem, count submatrices with top left element and sum less than k. We are given a zero indexed integer matrix grid and an integer k, and we need to return the number of submatrices that contain the top left element of the grid and have a sum less than or equal to k. This problem looks like it needs around 4 nested loops, but the real solution runs in just one path. Let me show you the trick here. Again, we are given a grid of numbers and an integer k, and our task is to count how many submatrices starting from the top left corner that have a sum less than or equal to k. As I said, at first glance, this looks like a classic brute force problem. Try every possible submatrix, calculate its sum, and check if it is valid. But that would take O of n to the power 4, which is way too slow. But there is a key observation here. Every submatrix always starts at position 0, 0. That means we don't need to try all submatrices. We only care about rectangles that grow from the top left. So instead of recomputing sums again and again, we build something called a prefix sum matrix. Each cell will store the total sum from the top left corner and all the way to that cell. To compute each cell, we use this formula. We take first, we take the current cell. Second, we add the value from above. Third, we add the value from left, and finally we subtract the overlap. We should write here if it exists, and the same for the value from the left if exists. So let's take an example. Let's use this matrix. It's put the values above each other, and we need to build our sum prefix sum matrix. So let's apply our formula. We will check the first element, which is 7, and then look at the top element and left element we don't have here. So this rectangle that has only value 7 already have k have the value or has the sum of this rectangle less than k, which is 18. So we will increment our result by 1 here. Then moving to the next element, which is 6, and again look at the top element and left element. If we have any of them, we add to the current value. We will add 7 to the 6, and that will give us 13. Again, this rectangle is less than 18, so we will increment our result by 2. And again, moving to the third element, which is 3, looking to top element and left element. We already have only the left element, and that will give us 16. Again, 16 is less than 18, and that will increment our result by 1. So moving to the next row, we have the value of 6. Looking at the top and left element, we only have the top element, so adding these values will give us 13. Again, 13 is less than 18, and that will increment our value, our result value to 4. And then we will move to the next element, which is 6. And as you can see here, we have both the top element and the left element. So in this case, we add to the current value the top and left element and subtract the overlap, which is the value on the diagonal. So that will give us the value of 6 plus 26 minus 7, and that will give us 25. 25 is greater than 18, so our result is still the same. And the final element, we have the value of 1. Again, we have the top and left element, adding them together to 1, that will give us 43. And then decrementing or subtracting the diagonal value, and that will give us the value of search, I guess. And again, this value is greater than 18, so our result is still the same. So we will return the final result, which is 4, as you can see here. So now let's move to the code. I'll define two variables n and m that hold the matrices size. So int n equals grid dot size and int n equal grid of 0 dot size. And also I'll define our res variable that will hold the final result. And then we will loop through the grid. But first, we need to define the prefix sum matrix. So let's define a 2D array. Let's name it prefix of size n. So that create a prefix sum matrix with the same size of the original grid. And then we will loop over the grid for I equals 0 and I is less than n and plus I, and then iterating over the column for j equals 0, j is less than m and plus j. As we have seen in the example, we first take the current value. So we will say prefix of I and j will equal our grid of I and j. So the prefix matrix now had the current value of the grid, and then we will apply our formula. So if I is greater than 0, 0, then the prefix matrix at location I and j, we will add to it the value of the on the top, and again we will check if j is greater than 0. That means that we have a value on the left, so the prefix will we will add the value on the left. And finally, we check if both I and j is greater than 0, and that means that we have a value on top and value on left. So if I is greater than 0 and j is greater than 0 as well, and at this point we need to subtract the overlap, which is the value on the diagonal, I minus 1 and j minus 1. And after this condition, we need to check if the total sum or if the total value at the prefix matrix is less than or equal to k. So if this value is less than or equal to k, that means that we already have a rectangle with total sum less than k, so that increment our result by 1, and at the end of this loop we will return our result. So let's run it to make sure it works correctly. Let's submit it. So as you can see, we can solve this problem in one pass with a clean and efficient solution. So the entire trick here is realizing this. You are not counting all submatrices, only the one starting from the top left. And that turns our time complexity from O of n to the power 4 to time complexity of O of n multiplied by m, which is the size of the matrix. So if this made things click instantly, you are thinking like a pro already. Please for me for more clean coding tricks. And that's all for today. Thanks for watching and happy coding. See you. Bye.